discussing first 15 problems of this mains contest in this video. The length of rectangular plastic sheet and width also given, the area of the plastic sheet. Here area is equal to length into breadth. Simple multiplication. Two 2.00 plus 0.01. So here it is 6 plus or minus 0.03 plus or minus 0.04. So this is very small, we neglect it. So answer is this. Here on hypothetical planet, when ball is thrown vertically upward with a velocity u from the top of a tower, it takes 18 seconds to reach the ground. It takes 18 seconds to the vertically up to reach ground. It takes 18 seconds. So concerned formula will be here projected with u. It reaches ground. Basic formula what we have is S equal to ut plus half radius. Take this as a reference line. Below this we write minus h projected upwards. The acceleration is this. Let us assume that vertically projected one reaches ground in t1 second. Say this is equation. Another is if same ball is thrown down with the same speed. Here it is not dropped one. It is thrown down with a velocity u. And in this case, minus h equal to minus ut with the same velocity half gt2 square. Let us assume that it reaches ground in t2. And now if the same ball is released from rest, dropped body, h will reach its ground in t3 seconds. It is a standard model. By simplifying this, we get t3 as root of t1 into t2. So 18 into 8, 144, which is 12 seconds. That's right. Here he given for a particle moving on a straight line, variation of acceleration as a function of time. So since it is a straight line passing through the origin, acceleration is kt. But he is asking displacement time graph. So once acceleration is this, dv by dt becomes kt. So dv here is integrating, we get kt square by 2 plus. Here at time 0, right? So velocity, right, 0 or something else also it can have. What he is asking is displacement ds by dt is equal to kt square by 2 plus c. ds will be kt square by 2 plus c dt. S here is so k by 2 t cube by 3 plus ct plus. It is a third degree. It cannot represent straight lines. This is a parabolic. Second one represents parabola, so this can't be the answer. This one. Fourth option is correct. Right? Simple example. If you take S is equal to T cube, T is 0, T is 1, T is 2, graph will like this. Time can't be negative, so it cannot extend. So fourth option is correct. Here from a great height, two projectiles are thrown simultaneously in a horizontal opposite direction. So one is thrown like this horizontally with a velocity u. Another is thrown like this with equal speeds. So in this direction, then at some what he says accelerate then the time after which the projectiles will move perpendicular to each other. After some time, its horizontal velocity remains the same, vertical velocity. Once it is projected horizontally, vertical velocity, initial velocity is 0. So after t seconds in vertical direction, velocity will be gt. So at this point P, velocity vector will be ui plus gtj. Here, at this point, so velocity is in this direction, so gt. So resultant velocity vector, here let me write v1 and this as v2 minus ui plus minus gtj. So velocity vectors are perpendicular, dot product is 0. That means ui plus gtj minus ui, here also it is minus gtj, minus ui minus gtj is equal to 0. So u square is g square t square, t will be u by g, 20 by 10. It takes in 2 seconds, velocity vectors are perpendicular. Two particles rotating on a circle have the time period 10 minutes. Time period means one particle to complete one oscillation, it takes 10 seconds. Another one take 10 minutes. Other one take 12 minutes. So this is a simple LCM problem. So after 60 seconds, after 60 minutes, first particle make 6 oscillations and reaches starting point. So within the same time, 60 minutes, second particle makes 5 oscillations and reaches starting point. So that means they meet again after 1 hour. Here, this question, he given friction also. Let us observe the forces which are acting on the 3 kg block. If you consider 3 kg block, one is applied force in opposite direction, frictional force, and here in the spring balance, restoring force, let us write tension, which is equal to 3A. So here, this as N1. So here N1 is nothing but 3G. So here F is equal to mu is 0.5. Okay, mu into N1 plus T plus 3A. This is one equation. Here tension, that is nothing but here it is a spring. In spring balance, the tension is nothing but restoring force. So let us denote that T, let us write T as Kx. Similarly, on 2 kg block, normal reaction, here restoring force acts, that is Kx minus 15 newtons minus frictional force is equal to 2A. Kx minus 15 mu N2G, here 2 into G is equal to 2A. So here you have two equations. What we have to find out is reading in the spring balance is nothing but Kx we have to find out. So first equation 60 mu N1. So here mu N1 is 0.5 into 3 into G, 30, it's 15 minus Kx is equal to 3A. So that is 45 minus Kx, 3A. Say equation 1. Here it is mu N2 will be mu is 0.5. N2 here is 2G, that is 2. You will get it as 10. Kx minus 15 minus 10 is equal to 2A, which implies Kx minus 25. Adding these two, we get 20 is equal to 5A. Acceleration is 4 meter per second square. Once acceleration is 4 meters, 25 minus 3A is Kx. That Kx here is 3 into 4, 12, 30. So that is the reading in the spring balance, restoring force. It's a conical pendulum which moves in a horizontal circle of radius r. It is length of the pendulum. Then when it comes to this place, tension, this angle is theta. Here it is, this one is theta. Alternate angles, it becomes 90 minus theta. Tension component. So in this direction, T sine theta. So which is balanced by centrifugal force. And here it is mg. T cos theta is mg. So T sine theta here is, so dividing one with other, we get tan theta as v square by r. Here theta is given as 60. V square will be root 3 r. Since it is moving in a circle of radius r, V will be r omega, r square omega V is g. R get cancelled. Omega square is root 3 g by r. So here tan 60 will be r by L, sin 60 is r by L. Root 3 by 2 is L here is 20 centimeters. That is 20 by 100, 1 by 5. So R will be root 3 by 10. So from here, omega square is root 3 g. R is nothing but root 3 by 10. Omega square is 10 square. Omega is 10. Time period is 2 pi by omega. So that is 2 pi by 10, 0.2 pi. This is the answer. Here, the direction of propagation of wave is decided by Poynting vector. S bar is equal to 1 by mu naught times E bar cross B bar. He is asking the direction of propagation of electromagnetic field. So electric field, he said minus Z direction, and magnetic field is pointing in Y direction. So that is 1 by mu naught. K cross J is minus I plus I. That means it is in positive X direction. Here, a block of mass M slides down a rough inclined plane of inclination 30 degrees with a constant speed through S distance. Coefficient of friction is mu. The work done by the weight. Here it is mg. So weight component is mg sin 30, which is mg by 2. Work done by weight is nothing but F into S, mg by 2 into S. That is S by 2. Your work done by friction means that gives you different answer. Your two ideal helical springs having spring constants. Different springs, different spring constants, but they are subjected to the same force. So F will be K1x, same F here is K2, I will write X1, it is X2. So here it is X1 is F by 20, X2 is F by K2 40. So once it is stretched by some distance, energy stored in the spring is equal to half K x square. So that is energy stored in the spring, which is half kx square. I'm writing like this, which is f square by 2k. So in case of first spring, energy stored is 60. So f square here is 120 into k1. that is 2400 newtons. So potential energy stored in second spring, which is F square by 2K2, 2400 by K2 is 40, so which is equal to 30 joules. Here it is. Disk is rolling. So rolling, it's a combination of two different motions. One is translation and rotation. So let us apply translation formula here. It translates because of its own weight. So tension acts upward direction. So equation related to translation is equal to this. So here it is, rotation, calculating torque with respect to center of mass. Here it is, there are two forces which are acting on this disk. One is tension. So torque is equal to F into perpendicular distance T into with respect to which point we are calculating torque, with respect to center of mass. So this force is at a distance r, force into perpendicular. Another force also acts, but acts through center of mass. So torque will be only T into r. So that which is nothing but I alpha. So here it is, since it is rolling without slipping, rolling without slipping, A becomes R alpha. Here I is nothing but mr square by 2, moment of inertia of a disk with respect to an axis passing through the center of mass. R get cancelled. So T becomes ma by 2. So here it is, mg is equal to ma plus T, ma plus ma by 2, 3 ma by 2, m get cancelled. Acceleration is 2g by 3. So here it is, we given g as acceleration, g as 9. So that is 6 meter per second. So we can answer this question in another way. Over an inclined plane, acceleration is g sine theta by 1 plus k square by r square. Here mk square is mr square by 2. K is radius of gyration. K square by r square is half. Here theta is 90 degrees. G by 1 plus half, which is 3 by 2. So this way also this problem can be solved. When capacitor plates are charged by a battery, and then plates are pulled apart with insulating hands. So here importance of insulating hands. If it is conducting hands, charge will pass from metal plate to conductor. If it is an insulating hand, charge remains there on the plates of a capacitor. So what changes occurs? Charge remains the same, first point, even after disconnection of battery. So capacitance decreases Why it decreases? Actually, it will not decrease, but plates are separated. Plates are separated means, so new distance will be d dash will be more than d. So 1 by d dash will be less than 1 by d. A epsilon naught by d will be the new capacitance is less than, capacitance decreases. Charge remains the same, no change. So this will not decrease. Potential difference, when charge remains the same, capacitance decreases, potential difference increases. So first option is correct. An artificial satellite is rotating in a elliptical orbit around the Earth. So the potential energy and kinetic energy, potential energy here is minus gmm by r, Earth mass, satellite mass, it is an orbit of radius. Kinetic energy will be gmm by 2r. So kinetic energy depends upon in which orbit it moves. Potential energy also depends on radius. So kinetic and potential energy are not constant. So angular speed also depends upon r, is also not constant. What constant is? So there is no external torque because of internal force of attraction. Satellite is moving around the Earth. So there is no external torque. So dl by dt is 0, which implies L is conserved. Here, this is interesting question. Generally, there is a chance of doing mistakes. Here it is point charge and charged body. It's a positively charged bodies always repel each other is wrong. Here, if you take one body comparatively having more charge with other body, so generally there is a force of repulsion between positively charged bodies. So if they come closer, with them, they come closer, negative charge will be induced on the smaller one. So which leads to attract. So here force of attraction exceeds force of repulsion. So this statement need not be correct. Two attracting bodies must be opposite. This is an example. So both are positively charged bodies. There is a possibility that they may attract. It is not compulsory. Two positive point charges. Here it is body. Here it is a. So equal point charges. So they definitely repel. And two opposite point charges. Point charges definitely they attract. Right. So fourth option is correct. So here, when a raindrop is moving down in air, that is raindrop is moving in air. that is viscous medium. So there is a force of buoyancy as well as viscous force 6 pi eta v opposes. Finally, it moves with a constant velocity, which is known as terminal velocity. The terminal velocity is proportional to r squared. So here, how many, if it clubs with another identical, so two drops are combined, then volume of bigger drop is 2 times volume of smaller drop. R cube here is this. So Vt by Vt bigger drop is R1 square by R2 square. That is R square by capital R square. So R square by capital R square means 2 power 1 by 3 R power R cube whole square. Here it is R cube, right? 1 by 3 whole square. So which is Vt by Vt, this is the bigger drop terminal velocity, 2 power 2 by 3 R square. So the terminal velocity of bigger drop is 2 power 2 by 3 times terminal velocity of smaller drop. That is first option is correct.